summation on your final column. 1500 plus 5.577 power 3 is equal to 7077. And then over here will be equal to 7500 plus by 5864.435 power 3 is equal to 871.935 times 10 to the power 3. Okay, so let me do it again. 5.577. 155 times by 5.577 power 3 by 435. 435. So 861.4, 861.435 power 3 plus by 7500.935. Okay, so from here, we know that our Y bar will be equal to 871.935 times 10 to the power 3 divided by 7077. 871.935 power 3 divided by 7077. So it's equal to 123.207 millimeters from the top. Okay, from the top. If you take it from the bottom, the answer will also be the same. Okay, so from here, we are going to do what? We are going to find IZZ. Okay, we are going to find IZZ for the what? Flange. Okay. Now this is where what I show you are really useful. Okay, remember what I show you? Once you create this table, you cannot go wrong unless your table is wrong. Right? Right? You have to check your table. Okay. So now when you do this now, right? You only need to focus on the what? On the table. I'm not even looking at the diagram. I'm looking at the where? Table. 1, 150, 10, cube, 12, plus 1500, 123, bracket, 123.207 minus 5 squared. We're good to go. Could you imagine without the table, by just looking at the what? Diagram to do it? You'll go bonkers. I went bonkers before. That's why I have permanent what? Head damage. Okay, so I don't want you to go what? Crazy yet. Okay. A lot of times students say that this course is a life-changing experience and a life-shortening one. So this will be equal to 20.972 times 10 to the power 6, okay, millimeter 4. While writing this out, there are some students, I don't know who they are. They asked the departmental chair if they can take this course in University of Toronto. Okay. I don't know why they want to do that. Some of you say, yeah, I know why, Eugene. Come on. So I checked. So the department make me check what is the equivalent cost in University of Toronto, and I found it. To do this course in University of Toronto, you have to take 2 courses. You have to take how many courses? 2 courses. So what does it mean? Discount. Yes or no? How many of you don't agree? Evans, you agree, right? Great value. Yeah, 350. I felt really offended when we want to take the course in University of Toronto. I felt really like offended. Then when I realized that it's 2 courses, I say go. Okay. Can you all see what I'm doing? Yes or no? Right? If you create the table and provided your table is done properly, you can't go wrong. I did not even need to look at the what? Figure. Please use this. Okay, I highly recommend this. Okay, because I've solved so much problem, close to 100 questions on this. No one in McMaster will solve more problem than me. Then okay, this helps a lot. We clear? So now we know our IZZ. So IZZ will be 20.972 times 10 to the power 6 plus by 44.722 times 10 to the power 6. Okay. So 20.972 power 6 by 44.722 power 6. So this is equal to 65.694 times 10 to the power 6 millimeter to the power 4, or in another words, 65.694 times 10 to the power minus 6 meter 4. In the term test, how our mark is this. If you got this part right, and this is worth half a mark, you get 0.5. And if you got this right, you get what? 0.5. We clear? Okay, break down your what? Break down your solution. Okay, this you can also check what? Better. Don't put everything in one equation, then everyone die. Are we clear? Okay, so these are the things that I hope you don't forget. Okay, right, where are we now? So we have our IZZ. Next, we are going to determine our IYY. So we find our IYY. So now, coming back to here, IYY is not that bad. Okay, why I say IYY is not that bad? Because based on observation, we know where is our what? Based on observation, we know that this is our what? This is the position of the what? Centroid. Yes or no? Visual. Okay. Likewise, we will still use brass as the what? Okay, you don't change down here, yeah? Once you use brass, always stick to what? Brass. Are we clear? If you change, you'll be in deep duda. Are we clear? Okay. So if you fix at brass, we do at brass. Okay. So if that's the case, this will be our what? Our width, because this is your y axis, this will be your width. And this distance will be your what? Will be your depth. Okay. So therefore, IYY, I'm going to deal with brass first, which is material number 1. So it will be 1. Our width is 10. Our depth is 150 power 3 divided by 12. Okay. So this is for our flange. And the next one will be for our web. So we know that this will be equal to 200 over 104. I'll write 200 properly. This will be equal to 200 divided by 104. The width is 290 and the depth is 10 cubed. Okay, and then the whole thing divided by what? Divided by 12. Okay, so this will be equal to 10 times 150 power 3 divided by 12 plus by 200 over 104 times by 290 times by 10 power 3 divided by 12 is equal to 2.859 or 2.85, yeah, 2.859 times 10 to the power 6 millimeter 4 or 2.859 times 10 to the power minus 6 meter 4. That's why using engineering unit will help you out a lot. Are we clear? Okay. So next, which is the most important part, is we're going to deal with the bending moment analysis. Okay. This part is very, very critical. Okay. Again, if you make mistake here, yeah, nothing good will happen. Okay. So again, I'll get both diagrams across. Okay. Now, question for you. We know that we have a force vector down here, and this is equal to 8.66 times 10 to the power 3, and we have a force vector in this direction, and it's equal to 5 times 10 to the power 3. And then we have a what? We have our centroid, which we have determined. So this is our centroid. Okay. Okay. Now, if that's a centroid, okay, this is where I don't think maybe you have seen this. Let me ask you then. Moment about Z. Can someone give me based on 8.66? 8.66 times 10 to the power 3 multiplied by what? So Z is in this direction. Multiplied by what? 2. Is there any other moments? Yes. Five times 10 to the power 3. And what is the perpendicular distance? Huh? No, it's this distance. That distance to the centroid, what do we calculate? What do we calculate? We calculate it to be equal to what? 123.207. So 123.207 times 10 to the power minus 3. Are we clear? Okay, so this will be equal to 8.66 times 2 plus by 5 power 3 times 1.23.207 power minus 3 is equal to 17.936 times 10 to the power 3 Newton meter. Okay, now there's something very important I want to tell you. We know that the failure region is here. Okay. When the applied force is perpendicular to the neutral to the centroid, the perpendicular distance is to the point of failure. i.e., you take the distance from here to here. Are we clear? Okay. However, when the applied force is parallel to the what? To the centroid, okay? The perpendicular distance is to the what? It's to the centroid. A lot of students get really confused. When the applied force is what? Perpendicular to the what? To the centroid, you take the distance to the what? To the point of failure. However, if the applied force is parallel to your what? Centroid, then you take the distance towards the what? Centroid. How are you guys doing? Not that bad, right? Okay, okay. I'll see you guys next week. Okay, next week we should be able to finish this.